This conference will now be recorded.
So good morning, my name is Joachim. I work at Know-How Solution in Sweden, and today I have Jukka and Mikko from Rugged Tooling to present for you a very exciting solution when it comes to network analysis and so on. So I will just welcome you again, and I will leave my word to Jukka. So I will also turn off my camera. So see you later.
Yes, hey, hello, thanks Joachim for the introduction, and good morning for everyone. My name is Jukka Ruotsalainen from Rugged Tooling. I work there as a senior sales manager, and I'm here with my colleague Mikko Karjalainen, and Mikko is our CTO. So Mikko, say hey to everyone.
Hello everyone.
Yes, and good to see you all here. So today's topic is the Rugged Tooling and the Rugged Tooling's solutions, and with the headline, how can your system cope cyber attacks on networks? So the agenda for today is short company intro by me. So I will go shortly through our products and offering, and then we will have a live product demonstration by Mikko. And of course, if you have any questions or anything comes to your mind, please ask, please comment. It will be nice to have an interactive conversation. So if you have any comments or you wish to ask anything, so how it could be used, or if you have some use case examples or any questions, just please ask. Any questions in this phase? Nope. So then we continue. So Rugged Tooling, what we do? We do quality assurance and monitoring of demanding IP. Yes.
Altså, det er jo igen det, hvor man siger, at det kan godt være, at man siger, at det bliver urealistisk med 3 måneder, og så som du siger, jamen, så det næstbedste, det er, at du kan få, når den ligger i Singapore, eller hvor fanden det nu er. Ja. Er det ikke der, man tænker?
Excuse me, could you repeat?
I think it was just attendees to join.
Okay.
Attendee, so no problem.
Yeah. Okay. Yeah. Yes. Okay. So welcome you also. So what Rugged Tooling's doing? We do quality assurance and monitoring of of demanding IP networks. The company is based in Oulu, Finland, and we have been 12 years in business, and we do have 3 products, and we have sold those 13 countries. The product range what we do have an IP network emulator. So basically it does deviate IP networks, so it will make jitter and all kind of disturbance to those networks. The networks itself, it can be like an autonomous mining machine, it can be a factory, it can be some like command control systems. Basically any IP network is suitable for this kind of testing. Then we do have IP load generator that basically generates loads to networks. Again, it can be any network, it can be some kind of web page, web service, it can be a factory control system. There is no limits. And then we do have also IP network health and data monitoring. So if you want to monitor your network, we do also have product for this. The team that we have, we do have world-class team of real-time IP-based software experience. We have done a lot of all kind of real-time and critical IP systems. We have programmed those, we have designed those, and last 12 years we have also we built a very nice product range up to these skills. On the right, you can see 2 examples of our products. The smaller one is 1 GB device, and the higher one is up to 100 GB. So the target that we are using these products is mostly high demand, like high number of users or like IoT sensors or sessions, and also real-time latency requirements is quite common. Typically, these requirements are in critical infrastructure, for example, like electricity networks or like in-vehicle communications. So if, for example, if you have a vehicle and you have a control bus there, that is critical communications. And also this is somehow connected to safety functions. So it means that if you have those like functional safety requirements, this is also quite nice. We do have a later example regarding this from one of our customers, Sandvik. So what Rocket tooling does, we visualize the crashing heavy IP traffic. So and also we usually use in those cases where the PC performance is not enough. So usually if you can do these kind of things with the PC, then we are not the right solution, and then you should use the PC solution. The company is 100% privately owned on Finland. Some of the examples we have been doing this quite long time, so we have had a privilege to have quite interesting customers and projects. The company started from Nokia, so Nokia was one of our first customers, and we started to develop our network deviation equipment for them. So, and they are actually still using our products. They are also maybe familiar for you. Ericsson also has been quite long time our customers. Some of the previous references we have had have been NATO Cybersecurity Center, and that's located in Estonia and Tallinn, and we actually participate to the NATO's Locked Seals cyber defense exercise in the start of this year. There was actually 35 countries participated at that exercise, and we are actually we're one of the technical partners for the cybersecurity center. So what the products are actually doing? So the root emulates live IP network conditions. So the key idea is that by using these kind of tools in your testing and quality assurance, it's possible to catch all the bugs and things that might be in the product and catch them in early phase before the product or the system is in production. And of course, as we know, it will save quite a lot of time and money if you catch these kind of problems in the earliest phase possible. So, and one of the typical use cases when you are using this is like timing resilience. So idea is that you make delays in the traffic and then check how the time critical systems are behaving. We also have some other examples later on by Mikko. Then we have the routes product, and the routes is a traffic generator. So it will generate traffic, and the idea is the same. So when you are having this QA function, automated testing, system testing, validation, and verification, the idea is that by stress testing the system in the early phase that you are developing, saves time and money by making these tests and preventing those failures and possible problems later in the production or when the product is ready and delivered to customer. Then we have one example here. So what you're actually seeing, this is our public reference. So what you are actually seeing in the left, that's a mining machine, and it's actually autonomous mining machine. It doesn't have any control place, so there is no human in that machine driving that. It's totally remotely controlled and partially autonomous. So the mining machine is several hundred meters under the ground, and it will operate independently. And it also has like a LiDAR sensor that helps it to navigate on the ground. The Sandvik had a challenge that due to functional safety requirements, they need to certificate these devices before they are able to sell those. And they have told us that those functional safety requirements, they are going striked by authorities all the time. And what they want to do is that they want to disrupt the internal control bus of the mining machine, that actually Ethernet IP, and then check that how the mining machine is behaving if the control bus is circumvent. So the idea is that if there are any problems in the control bus or in the traffic, there are any like corruption, duplication, reorder, drop, delays, the mining machine automation should detect those and correct those. And if that's not possible, then inform that has happened and also stop nicely, so and safely. And our route is actually perfect match to this. They are using our 1 GB version, so that's enough for the speed and accuracy of that kind of device. Any question in this phase? Okay, let's continue. And also, this is one example of what we did in the look at this exercise. So the idea is that if you have like a cyber range type of needs, so you want to simulate, for example, network attacks, or you want to simulate like stress test systems, we are also able to help you in that kind of needs. Regarding our sensor product, we call it Prescope, and that actually helps you to catch the traffic from the network. So if there's any traffic that you are interested, you can use our product to catch that. So if you want to know that who is talking with whom and what. That was my part. So Mikko, you could start to prepare your part. And while we are waiting Mikko, I would like to ask again that any comments, any questions? Okay.
I can just add also that if you have any question, you can type it in the chat as well if you don't want to open your camera, a microphone.
Yes, that's good notice, and we also sent you these presentations later on, so you can also read them again if you like.
Yeah.
Yes, please, Mikko.
Okay, thank you. So first, I have few slides I'm going to show you, and then I'm going to show you the GUIs of the product route and routes after these slides. So 2 products in this demo route. It's the IP load generator. So basically it generates network traffic. It can be stateless or stateful traffic, and traffic can be made from scratch as messages or based on some pcap file as streams. I will be showing you those from the GUI what those mean. And then root, the deviation emulator. This is man in the middle device. So root is data source, and root is man in the middle device. So it affects to that traffic that goes through the device actually, and it adds or modifies the traffic in real time, and it can be used to emulate real life network challenges in the lab. So route, like I said, it's a traffic generator. It can generate basically line rate of traffic. Yeah, there are some use cases here. So you can stress test your system basically with this device, or create some emulated DOS attacks or something like that. So the route traffic generation, It's basically first you need to create some sessions. I will be showing you those from the GUI. Also, what those mean, what kind of sessions there can be. But sessions are created, and then there are something we call variables. Those can be put into the messages or streams, so the traffic can be modified based on when it's multiplied. And basically, for example, IP addresses can be added to the traffic as variables. So traffic can be look like it comes from different IP addresses based on when the traffic is multiplied. And PCAPs can be used as payload, but in that case, you cannot put variables in the PCAP part of the data. So the payload, what comes from the PCAP file, that cannot be modified. It comes as it is in the PCAP. And these sessions, they are multiplied and can be looped over also when sending data to the line. So here you can see the traffic profile in the upper part. So multiply count. Here, if there's a 3 in the multiply count, you can see that one session is multiplied to 3 sessions. And ramp up interval, it means that what's the delay basically between these sessions. It can be set in microseconds. Start offset, of course, when the traffic is starting to send to the line, and then the loop over count, how many times the traffic is looped, and then the loop over time span is the time when the next loop starts. And then route. So this is the man-in-the-middle device. Like I said earlier, it modifies the traffic that goes through the device. There's something we call port pairs. So basically, there's port pair, 2 ports, 2 physical ports in the device that act as a port pair, and whatever goes in from port number 1 goes out from port number 2, modified by the deviations we tell the device to do, or otherwise also. So traffic goes in both ways. And basically it can be used to test your system or emulate the real life network challenges in the lab. And then there's one simple example of what there are, and something. So there's something called rules. I will be creating this kind of rules in the GUI also later. So there's something called default rule. That is something that is always there. And if there's no other rule there, everything goes through the default rule. But if there are some other rules that has some filters set, so basically here in this example, there are filters VLAN 100 and VLAN 200. So traffic that has this VLAN ID or VLAN tag, it will the traffic will go through these rules. And if the traffic doesn't hit these VLANs, so these filters, it goes through the default rule. And this is one way only shown here, but the other way is the same. And basically the other way, there's something called flow in the hardware or software in the hardware, and it creates different flows based on the different direction. Okay, so questions or comments at this point? I think there is something in the chat.
Yes. Maybe we should repeat that question if don't everyone see it. Does it work with encrypted traffic? Is a question.
Yeah, so that is the question. Does it work with encrypted traffic? So in root, well, we can modify the headers based on or the traffic on whatever point, but there currently it doesn't decrypt the traffic on any way. But we can, of course, traffic can be encrypted or payload can be encrypted, and we can modify the headers, for example, that are not encrypted. Okay, any other questions at this point? Or should we move to the quiz? Okay. So let's start with the traffic generator. So the GUI looks like this, and I'm going to open one previously made traffic profile. Let's see what this demo 2 has here. So here in this traffic profile, there are 2 different sessions created for this. And the first one is multiplied basically in this demo, but the second one is not. So this is sent only once, and this other one is sent many times. So it's multiplied and it's looped over many times. But this can be, you can change these values here in the, so if I want to multiply this 10 times, for example, I just put the number there and so on. And these sessions and traffic profiles can be saved as XML files here in this root product and used later on. So let's open this first session and see what's in there. So I just double click it and it will open. So here there are something called messages. So basically there's 2 messages created here, and they are just user just selects the protocol stack they want to use. So basically there's Ethernet, IPv4 and UDP, and then there's user data. And user data in this case, it's just some ASCII text, and there are some X's. These X's are actually IP addresses as strings. In the payload, I will be showing you the variables later that make these look like IP addresses, and this is the running number basically here in the content also. And these are the variables here, and those can be just drag and dropped here in correct places. They are put here all already in this example. So there are these IP addresses as strings and this content running number also. So variables, we can just put some default values. So we select what kind of what type of variable these are, and then put some default values to it. And then there's this increment value. So this increment means that, for example, content here is running number when the traffic is multiplied. So basically, it changes every time we multiply this or these messages in this session. And this loop increment, that's something that changes also the data or content of the data, but it changes when the session is looped. So in every loop, there's different IP addresses, different ports, and these IP addresses, those are basically the same but as a string in the payload. And then these can be also, when made new messages, those can be also just drag and dropped here. So they can be put there like that. No, let's not save that right now. And then the second one, this has something called stream inside, and that means there's a PCAP file as a base. So basically, there are streams, so PCAP files. Those are basically, there's one PCAP file, and it has been separated, or we have separated the directions of the traffic with these filter strings, basically, from the PCAP, and we sent those different directions in different streams, basically. And in this case, when the PCAP file is used, we can remove some protocol headers from the PCAP and replace them with our own. And in this, what we replace, we can put some variables in those replaced protocols, basically. So in the original PCAP file, there's no VLAN header, for example, in this case. But we have added that here and use that VLAN tag as a variable. So it changes. Let's see when it changes. It changes when the traffic is multiplied. So basically there are VLAN tags from 200 to 224 in this example. Okay, and then it doesn't show, so the variables cannot be put in the payload data. So I think there's a TCP payload here in the traffic or in the PCAP file. So we remove the original Ethernet and IPv4 and replace those with our own. And then the rest of the data comes from the PCAP file when traffic is sent to the line. Okay, so that's basically the two ways to create data or in these session profiles. Then we can, let's not say. So there are some more examples. So let's see simple DOS TCP SYN example here also. So basically, there are just some TCP SYN messages created here in the session profile, and then to get more or to get some same messages for each session, this has been multiplied 5 times here already, and then it changes every time that is multiplied here in the traffic profile. So just to get more data to the line, it has been done like this. And then let's see one more example. So there's simple zip client server example here. So this has some stateful data. Those were stateless sessions, basically what I showed you earlier. But this zip example has some stateful data here. So basically it looks like this. So there are some messages sent, and then there are these states that wait for this is client, so waiting for the server to respond and then continue with the next message and so on. So when everything goes right, there is this stream, RTP stream basically starting here. So there's a PCAP file that has the data that is sent when this stream starts. And then when it's over, it deregisters and so on. So this is pretty straightforward example of the stateful session that can be done with this GUI. Okay, so any questions at this point from this route? Okay, so let's continue to the root GUI. And it looks like this. And here, let's create one profile. So let's use this VLAN 100 and VLAN 200 that were shown in the slides example also. So now I've created two new rules that has these filter strings. So traffic that has these VLAN tags will have deviations we will be setting here. So those will be done to that traffic. So first deviation here in this route we have is this drop. So let's see, there's some selections can be made. So random drop as percents, it can be constant interval, bursty, or predefined pattern. Let's see what that has. So basically this predefined pattern, you can select what packets are dropped from each flow. So it doesn't, if there are multiple flows, it affects as in flow level basically. So if there are multiple TCP connections, for example, it will affect, if we want to affect to the third packet of the TCP connection, for example, it can be done for each flow, and it doesn't only affect to the whole or all flows as a total basically. So we can select what packets can be dropped here, or you can put something here and generate it also. So that's drop. Next deviation, it's bandwidth limit. You can limit the bandwidth of the flow, or it can be actually selected. Basically limiting bandwidth per flow is not so good. I think this will also work as in the whole traffic that goes through. Then there's delay. So we can add some constant delay here. So let's say 100 microseconds. And then there can be some jitter added to it. So let's say 5, for example. And then there's this jitter distribution function here. So there's normal distribution or uniform, or when there's jitter, it's always possible that the ordering of the packets changes when there's jitter. So if the ordering of the packets needs to be original as sent to the line, and it goes through this device and it needs to be the same, it doesn't have to change, these ordered modes can be used in that case. So these are basically the three important things here in the delay and jitter configuration. Then there is this reorder mode. So basically it means that packet ordering can be changed. For example, randomly reorder every 0.1% of the packets. And it can be select how many packets the offset is. So basically 1, 2, or 3 are the options here. Then corruption mode, it's something that changes the data, and it's 1 byte change for each corruption, and there can be 3 of these in each rule. So here there's random corruption, for example, or let's say value to corruption. So you can change byte value, select the offset of the corruption where it is put, and then change the value here. And there's also checksum calculations can be done. So IP and L4 checksums can be calculated with this corruption, or if there's case that user wants to test something that works without this checksum calculation, it can be set to none also. And here is the next one, but let's not put anything more there. Then next deviation, it's this duplication mode. So basically you can duplicate the packets, for example, randomly again, 1% of the traffic is duplicated. And you can select the duplication count here also. A length change mode, so the traffic or packet length can be changed. So you can add length to the packets or remove some bytes from it, or set some fixed size length to all packets. Data content modification is another way of changing the data. So there are some modification methods here. You can add some data to packets, change data, so you can do multiple changes, or overwrite. You can do one overwrite for data, or remove some data from the packet. So let's change, for example, TCP destination port to something else. So let's say 15,000, for example. So there are some protocols put here that can be selected, or you can use these offset based changes also. Then there's fragmentation. So basic fragmentation is just put some MTU here, for example, like that, and it fragments based on that MTU. And then there's also this advanced fragmentation. And then you can select for each fragment the size, for example, or the time. So you can change the order of the fragments. You can drop some fragments or multiply some fragments also. So this is advanced fragmentation. And then there's this bursty data in the end. So if there's constant traffic going through, it can be made look like bursty data or bursty traffic. Okay, so these are the different deviations, and then this profile can be saved. Let's save it as name test, for example, and that can be used later on. Then there's one thing more I'm going to show you from this root GUI. It's this time profile here at the bottom. So user can use this GUI manually, basically changing these values and pressing start, and then changing something, pressing update, reset, and so on. But if there's some kind of need for doing this more automatically, it can be done here with this timed profile. So let's add some new rules. So these are basically new rules, and based on this time that is set here at the top of this time profile, the engine software, the software that is running on the hardware, changes these values. So we can, for example, add more delay after 1 second, and then add even more after 2 seconds, and so on. And this profile needs to be sent only once to the engine software, and then that engine software handles the changing of these values to the rules. And these kind of time profiles, it can be looped also here. And this can be also used from the CLI. So basically, user can save these profiles and send those from the command line interface. So it's basically used for test automation. So usually there's some, for example, Python scripts that can be used to send these profiles to the engine software and automate the using like that. Okay, so any questions up at this point from root or roots? Both can be answered right now. Okay, so no questions. I think this is what I'm going to show you today.
I have one question, Mikko. When you do some kind of tests, like a denial of service test, how many of these specs or profiles do you need to create?
So you are talking about root, basically. Yeah. Well, it can be, like I showed you this example, SynFloat example here. So it can be done with one session, basically. So this is one example of this. Of course, there can be multiple sessions added here. So I think I have some let's see if I have some examples here. So we can add multiple sessions also in one traffic profile, but it depends on the test what can be used. So here are two different kind of attacks happening, and of course you need to calculate the amount of traffic that is sent, so the device can actually send the data to the line.
Okay.
Okay, then thanks Mikko for the presentation, and also thanks for know how to organize this meeting. It was good opportunity to show and tell a little bit our products.
Yes. So I want to thank you, Mikko and Jukka, and I would like to inform that if you have any more questions or you want to have a dialogue directly, not in this webinar, we can arrange with your customers. So just let us know. We will send you a presentation and recordings afterwards as well. So if you have colleagues that couldn't join today, you can share it with them. Okay. Thank you very much, and have a nice day.
Yes, thank you.
Thank you.
Yeah, thank you. Bye.
Bye bye.
Bye.